now, and I tried to put up a 30-minute video, and it wouldn't. It was 3 o'clock in the morning, it was still trying, but if you put it in 10-minute chunks, it's pretty easy. So we're going to have to remember to cut it off at 10 minutes. All right. We were hanging a teapot. So let's look, open up your notes to where we had the hanging object. Mine was a teapot, and it was in a form of equilibrium. So check your notes if your brain doesn't remember. What is the kind of equilibrium that this teapot was experiencing? Brendan, can you look there and tell me?
Is it static?
Right. Remember, Anabella, you're the one who wrote this up the other day. So static equilibrium, our teapot, and you were hanging other objects from your Christmas list on there. Are you with us, Jonathan? You need your notes out?
Oh, I thought you were tell us. Wait, never mind.
You thought what? Never mind.
I don't know. You said you'd tell us when to take notes.
Okay, this is it. We're almost it. This is we're starting from this point. This teapot was in static equilibrium. If it was in the other kind of equilibrium, where it was having the constant velocity, what was the name of that kind of equilibrium, Molly?
Dynamic.
Dynamic, right. So we're in static. We're going to push dynamic till later in this mod. We're going to stay static today and for the next couple of days. So here we have the teapot in static equilibrium with a special type of translational equilibrium, and that's all the definitions I'm going to do today. So if we know the weight, let's say this is where you start writing, Jonathan and everyone. Let's give it an actual amount. Let's say that the teapot had a 2.4. Did you feel that little teapot? It's pretty heavy. Didn't look like it, but it was about 2.4 pounds. So you had that drawing. Let's pretend whatever object you drew on your notes was also 2.4 pounds, or you can give it any weight. If 2.4 pounds doesn't make any sense for the object that you drew, put in some other weight, 10 pounds, half a pound, whatever. So my question is, this teapot is still, so there must be another force countering it. What was that new force that we learned about? Everyone? Tension. All right. All right, so tension is upward. In this case that I've drawn for you, what is the amount, what's the value of tension? How much tension? I need a number for this one to create this scenario. What is the tension? Abby, what do you think?
Would it be negative 2.4?
Actually, I should call that negative. So then what would your answer be?
2.4.
Right. Because the teapot is static and still, we know that the force down has to equal the force up. And so we usually call weight negative. I forgot to put the negative. So 2.4 is upwards. It's the positive 2.4 pounds. All right, we're going to build on that by looking at a problem like last night. And those who read it, could you follow what was going on there in that example with all the sines and cosines? All right, calculators out. We're going to write one more example, and then you're going to do a couple. That's all we have for today. I'm going to draw a picture. How's this showing up, Aaron, on the board work, okay? I'm going to have a picture, and the picture, what can we put on the picture? Here's a bed, and here's 3 little monkeys. 3 little monkeys. Oh, that's right, they were jumping on the bed. This is a new version of the song. This is a new version of the song. They do. I think
Mice or pigs? Or...
Yeah, they don't look like monkeys, do they? All right, this is my version of the 3 Little Monkeys songs. They're in bed and they're staying there. So this is a picture that I have hanging on my wall. You can put a different picture on yours. You don't have to use the monkeys. But you have to indicate that your picture, like mine, is 5 kilograms. Pretty hefty picture there. And it is hung on the wall by 2 wires. And the one wire goes this way. And it is at 30 degrees, and the other wire is at a slightly different angle, and it is 40 degrees. 40 degrees from this horizontal line there, imaginary line that is. So would you sketch that, please? And we will see that it's hooked to the ceiling like that. So we have a 5-kilogram picture hung by 2 wires, and one is at 30 degrees, the other at 40 degrees. We learned that these wires have a new force that we're studying called tension. So I'll call this one tension 1 and tension 2, and we are to find those. Find T1 and T2. All right. To do this problem, we're going to draw a picture of all the forces. And I'd like you to do all the horizontal ones in red and all the vertical ones in blue. And that's why I gave you those pencils. So, we're going to do the horizontals in red. So we'll start those. Tension 1, because it's at a diagonal, we learned that we can divide it into the x and y components. So we'll take our red and draw the red component, and if your pencil shows up enough and you have enough of a point, you can write the name of that force in red, but we're not going to name it just yet. We're going to draw all the forces, and then we can go up in blue. So I'm doing the horizontal and vertical component of T1. Notice it goes from the tail to the head, because you have to know what direction these are going on. So put an arrowhead on the red and an arrowhead on the blue. So, like that. So make sure it goes from the tail of this vector T1 to the head. Remember, we knew tension is always away from this object, so the yellow arrowhead is here, away from the picture that's hanging. So, all right, let's put in the red and blue on the other tension force. So this one's going to go from the tail to the head. Notice it goes to the left and then up. All right, that's all I need. I really need those colors. And there's one more force we have to add, and that's, can someone tell me, what is that one more force that I'm missing on the picture? Molly?
Is it weight?
Yes, the weight downward. All right, let's start our calculations now. Weight is the first one. We'll calculate then. So tippy tap, weight equals mg. So this is in kilograms, so that's a mass. So I want you to change it to weight. Weight equals mg. I'll switch to yellow. Blue might not show up too well. Weight equals mg. Tippy tap for me. 5 times 9.8. I need that number. Anyone? 49. And 2 people got it, confirmed? All right. So we know the weight of the picture from its mass. It's negative 49 newtons, because weight equals m5 times g, negative 9.8. So that's where the 49 came from. All right, we're going to go up here. Maybe I will. Does that show up at all, Aaron? The blue does?
Yeah.
It does? Maybe I will do it in blue then. It's up to you. At least I want the lines that you've drawn in blue. I don't care about the letters and numbers, but all right, so negative 49. Let's go up here and name these blue forces, blue, red, blue, red. So this one we learned, is it? All right, we're going to